Good morning. I am here to answer and discuss question number 31 and question number 32. So, question number 31 is, what is the essential difference between commutation in a DC generator and commutation in a DC motor? So, what is commutation? Commutation is the process of switching the field in the armature windings to produce constant torque in one direction. So, the primary nga involved in the commutation process are the commutator and the brushes. So, the commutator is a rotary electrical switch which reverses the current direction between the rotor and the external circuit. So, the commutator assures that the current from the generator always flows in one direction, and the brushes that ride on the commutator and make good electrical connections between the generator and the load, generator or motor and the load. So, in the DC generator, the commutator and brushes functions to convert the internally generated alternating current to a load applied direct current. So, in the DC generator, the commutator functions as an rectifier which converts alternating current into load applied direct current. Sa DC generator, in the armature na-generate dito og alternating current, then it goes to the commutator, then during the commutator, the process of commutation happens, which is the conversion of alternating current into applied direct current. So, while in the DC motor, the commutator and brushes performs an inverse function by converting the externally applied direct current to alternating current flowing in the armature conductors. So, in the DC motor, the commutation process is inverse or opposite to the DC generator. Okay? In the DC motor, ang gibalir siya sa DC generator, di ba? Kung sa DC generator, ang input is AC and the output is applied direct current, then in the DC motor, the input is the externally applied direct current, then it goes to the commutator, then in the commutator, the direct current is converted into an alternating current which flows into the armature conductors. So the commutator here in the DC motor functions as an inverter which converts an direct current into alternating current. So now let's proceed to question number 32. Describe the commutation process in a DC motor. So the commutation process that takes place in a DC motor is the process of converting applied direct current into alternating current in armature. Just like what I said in the question number 31, the commutation process that takes place in the DC motor is opposite or inverse sa commutation process in the DC generator. Here, in the DC motor, there is an externally applied direct current from the source which then goes to the commutator, and there in the commutator, the commutation process takes place and the conversion of direct current into an alternating current which flows into the armature. So now let's proceed to the problem solving. So I will answer question number 6. If the armature winding in problem 5 had 4 parallel paths, what should have been the generated voltage? So the given in problem 5 are, first is the number of poles, which is 4 poles, the armature speed 1200 RPM, number of slots in armature 55, number of conductors per slot 4, and the flux per pole, which is 2.62 times 10 to the power of 6 Maxwell, And since we are not using Maxwell, we are using Weber, so we will convert Maxwell into Weber. So in 1 Weber, there is 100 million Maxwell. So 2.62 times 10 to the power of 6 Maxwell times 1 Weber over 1 times 10 to the power of 8 Maxwell. So the answer is 0.0262 Weber. And last is the armature paths, which is 4. So now let's get the generated voltage. So the formula to get the generated voltage is generated voltage equals to number of poles times armature speed times number of conductors times flux per pole over 60 times the armature paths. So let's just substitute the values. So number of poles 4 times the armature speed 1200 times the number of conductors, and since we were not given the number of conductors, we were just given the number of conductors per slot and the number of slot. So we will multiply it, which is 4 times 55 and times to the flux per pole, which is 0.0262 over 60 times the armature paths, which is 4. So let's just do the math, and the answer is 15.28 volts. This is now our generated voltage. That's all. Thank you for listening.